Imagine a world where trust doesn't depend on banks, governments, or middlemen, where information is transparent, secure, and verifiable by anyone. That's the promise of blockchain technology. At its core, blockchain is a digital ledger, a way to record transactions or information so that it can't be changed, hacked, or deleted once it's verified. But blockchain's impact goes far beyond just power in cryptocurrencies like Bitcoin or Ethereum. It's revolutionizing industries, from finance and supply chains to healthcare and voting systems, by offering a new way to share data securely and transparently without relying on a central authority. It's not just a tool for digital money. It's a foundational technology that could redefine how the Internet itself operates in the coming decades. In this video, we're going to break it all down in simple terms: what blockchain really is, how it works, the key components that make it possible, and why it's becoming one of the most transformative technologies of our time. Whether you're completely new to the concept or just looking to finally understand it clearly, this lesson will give you everything you need to grasp blockchain confidently and see how it fits into the future of technology and finance. By the end of this video, you'll not only understand blockchain, you'll see why so many people call it the next Internet revolution. The story of blockchain begins in 2009 with the birth of Bitcoin, the first decentralized digital currency. At the time, people were still recovering from the global financial crisis of 2008, an event that exposed the weaknesses of traditional financial systems, systems that relied heavily on centralized banks and institutions to manage money, verify transactions, and maintain trust. When those institutions failed, the world saw how fragile centralized trust could be. Then came Satoshi Nakamoto, the mysterious creator or group of creators behind Bitcoin, who introduced a revolutionary idea: a system that allows people to exchange value directly, peer-to-peer, without needing a middleman like a bank to verify or approve transactions. The challenge, however, was trust. How could two strangers online exchange money safely without a central authority ensuring no one cheats or spends the same coin twice? That's where blockchain came in. Satoshi's breakthrough wasn't just the creation of Bitcoin itself, but the underlying technology that made Bitcoin possible: the blockchain. It served as a public, transparent ledger that recorded every Bitcoin transaction ever made. Once a transaction was added to the chain, it was verified by thousands of computers, called nodes, and permanently stored, making it virtually impossible to alter or forge. In simple terms, blockchain replaced trust in institutions with trust in technology. Over time, developers realized that blockchain's potential stretched far beyond Bitcoin. If it could securely record financial transactions, it could also be used to track ownership, contracts, identity, supply chains, and even votes. This realization sparked a wave of innovation that gave birth to thousands of blockchain-based projects, from Ethereum's smart contracts to NFTs, DeFi platforms, and enterprise-level solutions. In essence, Bitcoin introduced blockchain to solve the problem of digital trust. But what started as a financial experiment quickly evolved into a global technological revolution, one that's now reshaping how we store, share, and verify information across nearly every industry. So that's how it started, as a solution to the problem of trust in a digital world. But what exactly is blockchain? Let's break it down in the simplest way possible so you can understand how it actually works at its core. At its core, blockchain is simply a digital record-keeping system, like a notebook or ledger that's shared across thousands of computers instead of being stored in one central place. The word itself gives us a clue. It's made up of blocks and a chain. Think of a block as a digital page that contains a list of transactions or pieces of information. Once that page is filled, it's locked, timestamped, and linked to the previous page, forming a chain of pages. Together, these blocks create an ever-growing history of data that can't be easily changed or erased. This is why we call it a blockchain, a chain of connected blocks, each one permanently storing a record of what happened before it. To make it even simpler, imagine a Google Sheet that's shared with thousands of people all over the world. Everyone can see the same data in real time, and whenever someone updates it, that change must be verified and approved by the group before it becomes permanent. Once approved, the update is locked, and no one can secretly edit or delete it. That's exactly how blockchain works. It's a shared, transparent system that everyone can trust because no single person or company controls it. Now, what makes blockchain truly special are its three key traits. Transparency. Every transaction is visible to all participants. Nothing is hidden, so anyone can verify what's happening at any time. Security. Once data is recorded in a block, it's protected by strong cryptography and cannot be altered without the approval of the entire network. And decentralization. Instead of relying on a central authority like a bank or government, the blockchain operates across a distributed network of computers, ensuring no single point of failure or control. So in simple terms, blockchain is a shared digital ledger that records and secures information across a network of computers, making it transparent, tamper-proof, and decentralized. It's the technology that allows strangers around the world to trust each other, not because of who they are, but because the system itself guarantees fairness and accuracy. Now that we understand what blockchain is, the next question is, how does it work? Let's walk through the process step by step to see what happens each time a transaction takes place on the blockchain. Step 1. A transaction is initiated. Imagine Alice wants to send 1 BTC to Bob. She opens her wallet, enters Bob's public address, and signs the transaction with her private key. That signature proves the transaction really came from Alice without revealing her private key. The signed transaction, essentially a small packet of data that says Alice pays Bob 1 BTC plus a timestamp and fee, is broadcast to the blockchain network so other participants can see it. Step 2. The transaction is verified by network participants, miners or validators. Once the network receives Alice's transaction, nodes check it for validity. Does Alice actually own the coin she's trying to spend? Is the signature correct? Has the transaction already been spent elsewhere? Different blockchains verify this in different ways. In proof-of-work systems like Bitcoin, miners collect pending transactions and race to solve a hard cryptographic puzzle. The winner gets to propose the next block. In proof-of-stake systems like many modern chains, validators are chosen, often randomly but weighted by stake, to attest to the transaction's validity. Either way, the point is the same. Multiple independent parties confirm the transaction before it becomes permanent. Step 3. Verified data is grouped into a block. Verified transactions don't become permanent one by one. They're batched into a block. A block is like a page in the ledger containing dozens, hundreds, or thousands of transactions, a reference or hash to the previous block, a timestamp, and specific metadata, like the miner or validator ID, and a proof, the POW nonce or a cryptographic attestation. That reference to the previous block is critical. It links blocks together and builds the chain. If even one transaction in an earlier block is changed, the hash stored in the next block no longer matches. immediately revealing tampering. Step 4. The block is added to the chain in chronological order. After a miner finds the valid proof or validators reach consensus, the block is appended to the end of the chain and broadcast across the network. Every full node receives the new block, checks it independently, verifies the truth, revalidates transactions, and then adds it to their local copy of the ledger. Because each block points to the previous one, blocks form a time-ordered, tamper-evident record of history. Over time, blocks are layered on top of each other. The deeper a block sits under subsequent blocks, the more secure and irreversible it becomes. Step 5. The network updates, ensuring everyone has the same record. Once nodes accept the new block, they update their local ledgers so that Alice's transaction shows as confirmed on every copy of the blockchain. This is what people mean by single source of truth in a decentralized system. There isn't one authoritative database controlled by a company. Every node holds the same ledger and arrives at the same state independently. If a node is out of sync or malicious, honest nodes will reject its data, and it will fall back in line. Why this flow makes blockchain transparent, tamper-proof, and decentralized. Transparency comes from the fact that transactions in blocks are visible to participants on public chains. Anyone can inspect the chain, verify balances, and trace transactions without needing permission. Tamper resistance is built into the structure. Blocks are cryptographically linked through hashes, and consensus mechanisms make rewriting history computationally or economically infeasible. To change a past block, you'd need to redo the proof or outvote the network from that point forward, a prohibitive task on large, healthy blockchains. Decentralization is achieved because validation and storage are distributed across many independent nodes rather than concentrated in one server or organization. That distribution removes single points of failure and reduces the risk of censorship, unilateral data changes, or centralized control. Concrete examples to tie it together. When you send an ERC20 token on Ethereum, your wallet crafts and signs a transaction, nodes check your nonce and balance, miners or validators on Ethereum's POS system include the transaction in a block, and after several confirmations, your token transfer is final. In supply chain use cases, a manufacturer can publish a shipment record to a private blockchain. Each supply partner can verify that entry independently, and later audits can trace provenance without relying on a single company's paperwork. In both examples, the same step-by-step flow of submit, verify, pack into a block, append, and update provides reproducible, verifiable history. A quick note about finality and confirmations. Not every confirmation makes a transaction absolutely immutable immediately. Many blockchains use the idea of confirmations or additional blocks built on top to increase confidence. For Bitcoin, 6 confirmations, roughly an hour, is commonly considered strong assurance that a transaction is final. For other chains with faster block times or different consensus rules, finality may be achieved quicker or be mathematically guaranteed by the protocol. In short, blockchain works because it combines cryptography, economic incentives, and distributed consensus to turn individual transactions into a public tamper-evident ledger. That step-by-step process, from initiating a transaction to network-wide confirmation, is what enables trustless, transparent exchanges of value and information without relying on a central authority. That's the overall process, but to really understand the engine behind it, we need to look under the hood. Let's explore the main components that make the blockchain function the way it does. Every blockchain system is built on a few essential components that work together to make it secure, transparent, and autonomous. Understanding these core pillars will give you a clear picture of how blockchain actually operates beneath the surface. Blocks, the data containers of the chain. A block is like a digital container that stores a collection of verified transactions or records. Each block has three main parts: data, the actual information being stored, such as transaction details, who sent what to whom, when, and how much. Hash, a unique digital fingerprint of the block's contents, generated using cryptography. If even one letter or number in the block's data changes, the hash completely changes, making tampering instantly visible. Previous block's hash. This connects the current block to the one before it, creating the chain in blockchain. This chaining mechanism ensures that if someone tries to alter any past record, all subsequent blocks become invalid, protecting the entire ledger's integrity. Think of it as a stack of sealed boxes, where each box's label depends on the previous one. Change one, and the sequence breaks. Nodes, the backbone of the network. Nodes are computers that run the blockchain software and maintain its database. Every node stores a copy of the entire blockchain, and they constantly communicate to stay synchronized. Some nodes simply keep records and verify transactions, while others, like miners or validators, also help create new blocks. The key point here is decentralization. No single node has total control. If one node goes offline or becomes compromised, the rest continue to operate, ensuring that the blockchain remains available and secure. In public blockchains like Bitcoin or Ethereum, thousands of nodes scattered around the world keep the network alive 24/7. Consensus mechanisms. How the network agrees. One of blockchain's greatest innovations is that it allows strangers to agree on a shared version of truth without a central authority. This agreement process is called consensus. Different blockchains achieve consensus through different methods. Proof of work, used by Bitcoin, where miners solve complex mathematical puzzles. The first to solve it gets to add a block and earn a reward. POW is secure but energy-intensive. Proof of stake, used by networks like Ethereum 2.0, where validators lock up a certain amount of tokens as stake. They're chosen to create blocks based on their stake and reputation. This method is more energy efficient and scalable. Other variations exist, like delegated proof of stake, proof of authority, and proof of history, but all serve the same purpose, ensuring everyone agrees on which transactions are valid. Smart contracts, code that runs itself. Smart contracts are self-executing programs stored on the blockchain. They automatically carry out agreements when specific conditions are met. No middlemen, no delays. For example, imagine an insurance contract that automatically pays out if a flight is canceled, or a decentralized exchange where trades execute only when both parties meet predefined rules. These contracts are transparent, tamper-proof, and enforceable by code rather than trust. Ethereum popularized this concept, turning the blockchain from a simple transaction ledger into a programmable global computer, one that runs decentralized applications, or DApps, in areas like finance, gaming, and governance. Public and private keys, the foundation of security and ownership. At the heart of blockchain security lies cryptography, and specifically the use of public and private keys. The public key is like your blockchain address. Anyone can see it and send assets to it. The private key is your secret digital signature that proves ownership and authorizes transactions. When you send crypto or sign a transaction, your private key generates a unique digital signature that the network can verify using your public key. However, if someone else gets access to your private key, they can control your assets, which is why securing it is absolutely critical. Together, these 5 components, blocks, nodes, consensus mechanisms, smart contracts, and cryptographic keys, form the technological backbone of blockchain. Each plays a unique role. Blocks store data, nodes maintain it, consensus ensures agreement, smart contracts automate interactions, and keys secure ownership. When combined, they create a system that's open, reliable, and resistant to fraud. A digital infrastructure powerful enough to transform finance, business, and technology as we know it. Each of these components forms the backbone of blockchain, working together seamlessly to create something far greater than the sum of their parts. Now let's shift our focus to what truly makes this technology revolutionary, the key features that give blockchain its power, trust, and global appeal. What truly makes blockchain revolutionary isn't just how it stores data, it's how it changes the way people, businesses, and even governments can interact without depending on intermediaries. The magic lies in 5 defining features that together make blockchain one of the most powerful innovations of the digital age. Decentralization. Power without a middleman. In traditional systems, there's always a central authority, like a bank, government, or corporation, controlling the flow of information or money. Blockchain completely removes that single point of control. Instead, data is distributed across a network of computers, called nodes, all over the world. Each node has a copy of the blockchain and works together to verify transactions. This means no single entity can manipulate or shut down the system. Even if one node fails, the network keeps running. For example, Bitcoin doesn't rely on a central bank. It operates purely through its decentralized network of users. This shift in power distribution allows individuals to own their assets directly and participate in a global economy without permission or intermediaries. Transparency. Nothing hidden, everything verifiable. Transparency is one of blockchain's most trusted qualities. Every transaction that occurs on a public blockchain is visible to everyone on the network and can be verified at any time. Once data is recorded, anyone can trace where funds came from, how they moved, and where they ended up. Imagine a financial system where you can audit transactions without needing an accountant, or a charity where donors can see exactly how their money is spent. That's the kind of accountability blockchain introduces. This openness builds trust through visibility rather than secrecy. Immutability, the power of permanent records. One of blockchain's core strengths is that once a block is added to the chain, it cannot be changed or deleted. This quality is known as immutability. Because every block links to the one before it using cryptographic hashes, altering any single record would require changing every block after it, a task practically impossible due to the immense computing power required. This feature makes blockchain a reliable system for preserving truth, whether it's tracking ownership of digital assets, recording medical data, or verifying supply chain movements. Immutability ensures the history remains intact and beyond manipulation. Security, protected by cryptography and consensus. Blockchain's security is built on layers of cryptographic algorithms and collective verification. Every transaction is encrypted and signed digitally with private keys, while consensus mechanisms like proof of work or proof of stake ensure that only valid transactions are added to the chain. Because there's no central database to hack, and because thousands of nodes confirm every change, blockchain is incredibly resistant to fraud or tampering. Even if a hacker managed to infiltrate one part of the system, they would need to control over 50% of the network's computational power to alter records, an almost impossible feat on large networks like Bitcoin or Ethereum. In essence, blockchain replaces trust in people with trust in mathematics and code. Trustless system. Collaboration without knowing or trusting each other. In the traditional world, transactions rely on trust. You trust your bank, your payment processor, or the other party in a deal. Blockchain introduces the concept of a trustless system, where participants can transact securely without needing to know or trust one another. This works because the blockchain itself acts as the referee. The rules are enforced by code and consensus, not by human judgment. For instance, when you send Bitcoin to someone across the world, you don't have to trust that person. The blockchain protocol ensures that once the transaction is confirmed, it's final and irreversible. This model opens the door to borderless, permissionless collaboration. Anyone, anywhere, can interact economically or exchange information safely through blockchain without intermediaries. When you combine these features, decentralization, transparency, immutability, security, and trustlessness, you get a system that is virtually incorruptible, globally accessible, and self-governing. That's why blockchain is often compared to the invention of the Internet, not just as a technology, but as a paradigm shift. It replaces trust with truth, control with collaboration, and centralization with empowerment. This is what makes blockchain not just powerful, but transformational, a foundation for the next era of digital innovation. However, while these features define what makes blockchain powerful, not all blockchains are designed the same way. Their structure and accessibility can vary greatly depending on their purpose. So let's explore the different types of blockchains and see how each one serves a unique role in the digital ecosystem. Just like there are different types of roads designed for different purposes, highways for public travel, private lanes for restricted use, and toll roads shared by specific groups, blockchains also come in different forms, each tailored to fit particular needs. Understanding these types is key to knowing how blockchain technology is applied across industries. Let's explore the three main categories. Public blockchains: open, permissionless, and transparent. Public blockchains are the pioneers of decentralization. They're open to everyone. Anyone, anywhere can join the network, verify transactions, or even contribute to maintaining it. No single authority controls who participates or how the system operates. The most popular examples are Bitcoin and Ethereum. In Bitcoin's case, anyone can run a node, mine blocks, or view every transaction ever made since 2009. Ethereum, on the other hand, takes this openness further by allowing users to build decentralized applications, dApps, and smart contracts directly on its blockchain. Public blockchains are governed by consensus mechanisms like proof of work or proof of stake, which keep them secure and tamper-resistant. Their transparency means that all transactions are visible to everyone, which helps prevent fraud and manipulation. However, this openness comes at a cost. Public blockchains can be slower and require higher computational power to maintain security. Still, they remain the foundation of the decentralized world and the heartbeat of cryptocurrencies. In short, public blockchains are for openness, inclusivity, and global participation. Private blockchains: controlled, fast, and business-focused. Unlike public networks, private blockchains are closed systems controlled by a single organization or a defined group. Access is restricted, meaning only authorized participants can view, validate, or add transactions. These blockchains are ideal for businesses and enterprises that need privacy, control, and efficiency. For example, a bank or supply chain company might use a private blockchain to record transactions securely without exposing sensitive data to the public. Since participation is limited, private blockchains are faster and more scalable than public ones. They can handle large transaction volumes with lower costs and greater control. But this also means they sacrifice decentralization. Trust lies with the organization managing the network. A good example is Hyperledger Fabric, an enterprise-grade private blockchain developed by IBM and the Linux Foundation, often used for corporate solutions like supply chain tracking or interbank settlements. In essence, private blockchains are about efficiency and confidentiality within trusted environments. Consortium or hybrid blockchains, the best of both worlds. Some use cases require both the transparency of public blockchains and the control of private ones, and that's where consortium or hybrid blockchains come in. A consortium blockchain is a collaborative system managed by multiple organizations rather than a single entity. Each participant, like banks, logistics companies, or government agencies, operates a node and shares responsibility for verifying transactions. This shared governance model ensures both trust and accountability among known participants. A hybrid blockchains, on the other hand, blend private and public features. For example, a company might use a private blockchain for internal processes, but connect it to a public blockchain for external verification or audits. A practical illustration would be a global shipping network. Internal data about shipments remains private, but delivery confirmations could be verified publicly to ensure authenticity and transparency. Consortium and hybrid models are becoming increasingly popular for sectors like finance, healthcare, supply chains, and government services, where collaboration and trust are essential, but full transparency could compromise privacy. To summarize, public blockchains empower openness and decentralization. Private blockchains emphasize control, privacy, and speed. Consortium or hybrid blockchains offer a balanced solution, combining cooperation with selective transparency. Each serves a distinct purpose, and together they showcase blockchain's incredible versatility. Whether powering global cryptocurrencies or streamlining enterprise operations, the right type of blockchain is chosen based on one key factor: how much trust, transparency, and control the system requires. Now that we've explored the different types of blockchains and how they operate, the next big question is, where does all this innovation come to life? Let's dive into some real-world applications and see how blockchain is reshaping industries across the globe. Blockchain technology is no longer just the foundation of cryptocurrencies like Bitcoin. It's rapidly becoming a transformative force across multiple industries. Its ability to provide transparency, security, and decentralization makes it ideal for solving real-world problems where trust, traceability, and authenticity matter most. Let's explore some of the most impactful use cases that show how blockchain is reshaping the modern world. Finance, the birthplace of blockchain innovation. Finance was the first and most natural home for blockchain. Cryptocurrencies like Bitcoin and Ethereum proved that people could send money directly to one another without banks, intermediaries, or even borders. Transactions that used to take days and incur high fees can now happen in minutes or seconds, 24/7, anywhere in the world. Beyond crypto, blockchain has also enabled DeFi, or decentralized finance, a financial system that runs entirely on smart contracts instead of traditional institutions. Platforms like Uniswap or Aave allow users to lend, borrow, and earn interest without ever needing a bank account. Cross-border payments, too, have been revolutionized. Companies like Ripple use blockchain to help banks transfer money internationally faster and cheaper, reducing the friction that plagues traditional wire systems. In short, blockchain is rebuilding the world of finance to be more open, efficient, and global. Supply chain, from farm to table with full transparency. In supply chains, blockchain acts as an immutable tracking system, recording every step a product takes from its origin to the end consumer. Each participant, farmer, manufacturer, shipper, retailer, adds data to the chain, ensuring authenticity and traceability. For example, Walmart and IBM have used blockchain to track food shipments. If a contamination issue arises, they can instantly trace the problem back to its source. Something that used to take weeks now takes seconds. Luxury brands like Louis Vuitton and De Beers are also using blockchain to combat counterfeiting by proving the authenticity and origin of their products. This level of transparency builds trust between producers and consumers, eliminating fraud and inefficiency. In essence, blockchain turns complex global supply chains into visible, verifiable, and trustworthy systems. Healthcare, securing patient data with precision. Healthcare systems around the world struggle with fragmented records, data breaches, and lack of interoperability. Blockchain offers a solution by providing a secure, decentralized record of patient data that can be shared only with authorized individuals. Imagine a patient traveling to another country. With blockchain, their medical history could be instantly and securely accessed by doctors, avoiding repeated tests and errors. Projects like MedRec and Burst.IQ are pioneering such solutions, ensuring that medical data is both private and portable. Blockchain can also track pharmaceuticals from production to delivery, preventing counterfeit drugs from entering the supply chain. This isn't just innovation, it's potentially life-saving technology. Voting systems, trustworthy and tamper-proof elections. In many parts of the world, voting systems are plagued with concerns over fraud, manipulation, or lack of transparency. Blockchain offers a path toward verifiable and tamper-proof digital voting. Each vote can be recorded as a transaction on a blockchain, transparent, traceable, and impossible to alter once confirmed. Voters can verify that their votes were counted without revealing their identity, and authorities can audit the process with full transparency. Countries like Estonia and pilot projects in the US and Japan have already begun testing blockchain-based voting platforms, showing that this technology could one day ensure true democratic trust in elections worldwide. NFTs and gaming, the rise of digital ownership. In the digital world, owning something has always been tricky. How do you prove you truly own a file that can be copied endlessly? Blockchain solved that problem through NFTs, or non-fungible tokens, unique digital assets recorded on the blockchain. Artists, musicians, and game developers are using NFTs to create, sell, and authenticate digital goods. Gamers can now truly own their in-game items, weapons, skins, or characters, and even trade them outside the game ecosystem. Games like Axie Infinity and platforms like OpenSea have turned blockchain gaming and collectibles into multi-billion-dollar industries. NFTs also extend beyond art and gaming. They're being explored for digital identity, real estate ownership, and intellectual property rights. It's a new economy of verifiable digital ownership. In summary, blockchain's real-world applications reach far beyond cryptocurrency. It's transforming finance, supply chains, healthcare, governance, and digital entertainment, proving that it's not just a trend, but a technological revolution reshaping how we exchange value, verify truth, and build trust in a digital world. From sending money across borders to ensuring the authenticity of the food on your plate, blockchain's message is clear. Trust no one, verify everything, and let technology handle the rest. However, no technology is without its flaws. For all the innovation and possibilities blockchain brings to industries worldwide, it still faces significant challenges that slow down its full potential. From scalability and energy consumption to regulatory uncertainty, these hurdles remind us that blockchain, though powerful, is still evolving. Let's take a closer look at the key limitations standing in its way. While blockchain has captured global attention as a revolutionary technology, it's important to recognize that it's not without its challenges and limitations. Understanding these realities helps us see blockchain from a balanced perspective, not just as a futuristic miracle, but as an evolving innovation still finding its place in the world. Scalability issues: the speed versus decentralization dilemma. One of blockchain's biggest hurdles is scalability, the ability to handle large volumes of transactions efficiently. Unlike centralized systems that can process thousands of transactions per second, blockchains like Bitcoin and Ethereum often manage only a handful in the same time frame. This limitation comes from blockchain's design. Every transaction must be verified and recorded by multiple nodes across the network. While this ensures security and transparency, it also slows things down dramatically. During times of high activity, transaction fees can spike, and confirmations may take minutes or even hours. Developers are addressing this through solutions like Layer 2 scaling, for example, Lightning Network and Polygon, and sharding, which aim to increase transaction capacity without compromising security. Still, the balance between speed, cost, and decentralization remains a delicate challenge. Energy usage: the environmental cost of consensus. Another major concern is blockchain's energy consumption, particularly with systems that use proof of work, the mechanism behind Bitcoin's mining process. Miners compete to solve complex mathematical puzzles requiring enormous computational power and electricity. In fact, at one point, Bitcoin's network was estimated to consume as much energy as some small countries. This raised alarms among environmental groups and policymakers, questioning the sustainability of such systems. However, progress is being made. Newer blockchains, including Ethereum after its merge upgrade, have transitioned to proof of stake, reducing energy use by over 99%. The shift toward greener consensus mechanisms reflects blockchain's ongoing evolution toward environmental responsibility. Regulation: the legal gray area. Blockchain and cryptocurrency exist in a world where laws are still catching up with innovation. Governments worldwide are grappling with how to classify, tax, and regulate digital assets. Some countries, like Switzerland and Singapore, have embraced blockchain-friendly policies, encouraging innovation and growth. Others, however, have imposed strict restrictions or outright bans due to concerns about fraud, money laundering, or loss of control over national currencies. This regulatory uncertainty creates challenges for developers, investors, and businesses trying to operate legitimately within the space. Until clearer global frameworks are established, the blockchain industry will continue to face legal ambiguity and compliance challenges. Adoption barriers: bridging the knowledge and access gap. Despite its potential, blockchain remains technically complex for most people. Setting up wallets, managing private keys, or understanding gas fees can be intimidating for newcomers. This lack of user-friendly interfaces in education slows down mainstream adoption. Additionally, many businesses are still cautious about integrating blockchain due to uncertainty around cost, scalability, and long-term viability. For blockchain to reach its full potential, simpler tools, better education, and stronger user experience will be essential. In summary, while blockchain represents a powerful shift toward decentralized trust and digital autonomy, it's still a work in progress. Scalability, energy consumption, unclear regulation, and user adoption remain significant obstacles. But just as the Internet overcame its early challenges in speed, accessibility, and skepticism, blockchain too is on a journey of refinement. By acknowledging its limitations today, innovators can focus on solving them tomorrow, bringing us closer to a world where blockchain's promise of transparent, efficient, and secure digital interaction becomes a seamless part of everyday life. And guess what? Even with these challenges, the story of blockchain is far from over. In fact, every limitation has inspired new waves of innovation. Around the world, developers, researchers, and visionaries are working tirelessly to make blockchain faster, more efficient, and seamlessly integrated into everyday life. So, what does the future look like for this groundbreaking technology? Let's take a glimpse ahead. The future of blockchain is one of constant evolution, where innovation continues to refine what's possible in our digital world. What began as a simple ledger for Bitcoin has now expanded into a foundation for a new kind of internet, one that prioritizes trust, transparency, and ownership. As we look ahead, the path forward for blockchain is shaped by groundbreaking developments and visionary goals that go far beyond cryptocurrency. Layer 2 scaling, solving the speed and cost problem. Scalability has long been blockchain's Achilles heel, but that's changing fast. Layer 2 solutions like the Lightning Network for Bitcoin and Polygon for Ethereum are revolutionizing how transactions are processed. Instead of recording every transaction on the main blockchain, these systems handle them off-chain first, then settle the results back on the main network. The result? Faster, cheaper, and more energy-efficient transactions without sacrificing decentralization. In the future, this approach could allow millions of people to use blockchain seamlessly for daily transactions, whether it's paying for coffee, sending remittances, or interacting with decentralized applications or dApps, all in real time. Interoperability, bridging the blockchain islands. Currently, blockchains function like isolated islands. Bitcoin, Ethereum, Solana, and others each operate in their own ecosystem. Interoperability aims to connect these islands, allowing data and assets to move freely between them. Projects like Polkadot, Cosmos, and Chainlink are pioneering this space, building protocols that let blockchains communicate securely. Imagine a future where you can send Bitcoin on the Ethereum network or use data from one chain to trigger actions on another. That's the power of interoperability, a unified blockchain universe that behaves more like an interconnected web than a collection of silos. Web 3, redefining the Internet. Blockchain is also the backbone of Web 3, the next generation of the Internet, built around decentralization and user empowerment. Unlike today's Web 2, where tech giants control platforms and data, Web 3 gives individuals ownership over their digital identities, assets, and content. In this new model, your wallet becomes your online identity, granting access to apps, games, and financial services without the need for usernames, passwords, or middlemen. It's an internet owned by the users, not corporations, where blockchain ensures fairness, transparency, and accountability at every level. AI integration. Smart systems meet smart chains. The fusion of artificial intelligence, AI, and blockchain is unlocking entirely new possibilities. AI can analyze blockchain data to detect fraud, optimize trading, or even automate governance within decentralized organizations. Meanwhile, blockchain ensures that AI decisions are traceable and transparent, preventing bias or manipulation. In sectors like healthcare, supply chain, and finance, the combination of these two technologies could lead to self-improving, trustworthy systems that manage vast amounts of data securely and intelligently. Blockchain in the next decade, a world transformed. Looking ahead, blockchain will likely become invisible yet indispensable, woven into the fabric of everyday life. In finance, it will power faster global payments, tokenized assets, and programmable money. In digital identity, blockchain will help people prove who they are without sharing unnecessary personal data. In governance, it could enable transparent elections, tamper-proof records, and decentralized decision-making at scale. Imagine a world where land ownership is verified on blockchain ledgers, medical records are secure yet accessible globally, and every online transaction leaves a transparent, auditable trail. That's not science fiction, it's the direction blockchain is heading. Stay curious, stay informed. Blockchain is still in its early chapters, and the most transformative breakthroughs are yet to come. The innovators of tomorrow are the learners of today, those who take the time to understand not just what blockchain is, but why it matters. As the technology evolves, stay curious and keep learning. The next wave of opportunities will belong to those who recognize blockchain not merely as a tool for profit, but as a platform for progress, shaping how we interact, transact, and trust in the digital age. Because the future of blockchain isn't just about technology, it's about empowering humanity through trust, transparency, and true digital freedom. And that brings us to the end of our journey through the world of blockchain, from its humble beginnings with Bitcoin to its rapidly evolving future shaping industries worldwide. We've explored what it is, how it works, and why it matters. Now, let's take a moment to reflect on the key lessons and leave you with one final takeaway to guide your blockchain journey forward. Blockchain is more than just a buzzword. It's a revolutionary technology redefining how we store, share, and verify information. Throughout this lesson, we've uncovered what blockchain truly is: a digital, decentralized ledger that records transactions in a secure, transparent, and tamper-proof way. We explored how it works, from the creation of individual blocks to their verification and permanent addition to the chain. We also examined why it matters, not just in cryptocurrency, but across industries, from finance and healthcare to supply chains and digital identity. The key takeaway is simple but powerful. Blockchain is about trust through technology, not through intermediaries. It removes the need to rely on central authorities and replaces them with transparent systems where truth is verified by code and consensus. That's why it's often called the backbone of the new digital economy. But remember, blockchain is still evolving. The innovations we see today are just the beginning. As technology advances, new opportunities, challenges, and breakthroughs will continue to emerge. The best way to stay ahead is through continuous learning and curiosity. Whether you're an investor, developer, or enthusiast, understanding blockchain will be one of the most valuable skills in the digital era. At Crypto Education Zone, CEZ, our mission is to simplify complex crypto topics so you can master them with confidence. If this lesson helped you understand blockchain better, don't forget to like, share, and subscribe for more deep, practical, and easy-to-understand lessons on crypto and blockchain technology. Because here at CEZ, we believe that knowledge isn't just power, it's your greatest asset in the world of crypto.